Hi there folks, welcome to CompTIA Network Plus. Today's topic is subnetting, more specifically simplifying subnetting. Why am I saying it like that, you might ask? Because we're going to be simplifying the living heck out of it. That is why. And before we jump into the gist of things, if you guys haven't done so already, please give the video a like so more people can see this video. And if you'd like to know when the next lessons comes out, of course, go and subscribe. Alright, so first things first, what is this magical beast called subnetting? Well, folks, it determines how many networks you have. So when you go and do this magical thing called subnetting, it will allow you to determine exactly how many networks you have in your environment or in your client's environment. All of these things we're going to go into in just a second. The second thing it does is it determines how many IP addresses you have in each of those networks. So if you, for example, want 2 networks in your company environment, you will have a certain amount of IPs available on those 2 networks. Now, something else it also does is it allows you to subdivide your network. Digitally speaking, of course, it allows you to organize it. Now, when we do subnetting, for those of you that have a fair understanding of what it is, it's not so much used for security per se. It's more for structuring your network and organizing it, digitally speaking, of course. So, where do I go about actually configuring my subnetting? Now, most commonly, this will probably be done on a computer, desktop, laptop, server, something like that, by going into your network and sharing center, and of course, just configuring your IP address along with your subnetting. That will, of course, look something like this picture that I've got up for you guys right now. But it's, of course, not limited to doing it on a computer. This can be done in many places, in many cases. I mean, on the server alone, it could not just be the network and sharing center. Maybe you're configuring this in your DHCP server. This could perhaps be on something like your firewall. This could perhaps be on something like your router, your access point. There's many places where you can go and configure subnetting, and there's many reasons why you would be doing it. So now we have an idea more or less, give or take, where you would be configuring this, which brings us to my next question. How do you actually do this thing called subnetting? And how do you know actually what to go and fill in when you do it? So it's one thing to know where to go and do it, but it's an entirely different can of worms to know what to actually fill in there and what it actually means and what it's actually going to do. All right, so to help you guys actually understand this as quickly as possible and as easily as possible, I mean, like I said, to simplify the living heck out of it, I'm going to give you guys a little table that I used since 2010. So let me just draw it here for you guys. All right, so there we go. Now, this little table is not complete. There's actually more columns I can go and add, but that's moving into more advanced networking territory like Cisco, Huawei, that kinds of stuff. So for now, it should serve its needs. What we have here on the left is the subnet mask. So you'll find it the one way at the bottom on that little category there, 22255.0. That might look familiar to you guys. Usually when someone, maybe you, maybe a fellow technician, goes and types in an IP address, you'd find that that's usually the default subnet mask. Now, when you type in that subnet mask, or when it goes and auto-completes itself, that gives you a certain amount of IP addresses that you can go and use in that network. So there's a certain amount of devices that can go and connect to that network. And once you've reached that certain amount, any additional devices you go and add to that network will basically run out of IPs. They will not have any IPs. There's no extra IPs available. So yeah, now, if you've got a 0 at the back, that means you're going to use that full network, all of it. And that network is a Class C network. How I know that is by looking at the 22255. So if the first 3 octets we have there is 22255, so it's 255, 255, 255. If the first 3 octets is 255, that is considered a Class C network, folks. Class C consists of about roughly 256 IP addresses, of which 254 are usable. If only the first 2 octets, not first 3, only the first 2 octets are 255, that will be considered a Class B network, which is much bigger than a Class C. Class B has about 16,000 odd IP addresses. If you go and look at the subnet and you find it's only the first octet that's 255, that will be a class A network, which is approximately 16 million odd IP addresses. That's a lot, right? So you can see clearly there's a difference between these networks. So class C, class B, class A, you cannot even begin to compare the bunch between one another. You also get class D, in case anyone's wondering. Class D is experimental. We wouldn't worry about that for now. You don't need to know about that now. So for now, I'm going to keep it to class C because I want to simplify the living heck out of this. Now this table of mine can actually extend all the way to class A, completely the whole class B, the whole class A as well. Now looking at this list in front of us, if we look at the last one there, the bottom one, the 22255.01, the common one, the default one, whatever we want to go and call it, that gives us 256 IPs, of which 254 are usable. Why am I saying it like that, you might wonder? Because the first IP address and the last IP address in every network is never usable. They are reserved for broadcast address and network ID. Not something you need to worry about immediately. That's going to be covered in a different video later on in this course. But for now, just know they are reserved. So with that in mind, you would find that the IP address column there, I've added a -2. You might have thought it was a -2, but it's actually a -2. So it's a -2 just to remind us that in every network you can never use the first IP or the last IP because they're reserved. So looking at the normal 22255.0 we have here at the bottom, I've got the full class C to myself, which consists of 256 IPs, of which I can only use 254. So that's why I've got a -2 there behind the 256. Cannot use the first one, cannot use the last one. If you look at the one right above that, the 22255.128. So if I would have gone and changed that 0 at the back with a 128 instead, that would give us two networks. You can see it's two networks there on the right, two networks of 128 IP addresses each. In both of those two networks, you cannot use the first IP in each of them. You cannot use the last IP address in each of them. And it's the same procedure is going to keep continuing all the way to the top of this little table of ours. So if we go up another one, you'll see that we've got four networks of 64. So I basically just keep taking that 256 and I just keep dividing it. So if I divide it by 2, divide it again by 2, divide it again by 2, eventually all the way at the top here, you're going to end with 64 networks of 4 IP addresses each. And in each of those 64 networks, which only have 4 IP addresses, you cannot use the first or the last one, which means you only have 2 IP addresses left in those networks. So the only thing you'll really notice that changes in the subnet mask is the last digit. Now those last digits, I did not suck them out of my thumb, in case anyone's wondering. They're not just magical numbers or random numbers. There's a whole math behind this. And there's actually many ways you can go about working it out. But just looking at this table, you can already start seeing a pattern. If you take that 256 we've got way there at the bottom in the middle, and you subtract 128 from that, what do we get? 128, which is where the 128 comes from. There with this subnet it says 22255.128. If I take that 256 and I subtract the 64 from it, what do I get? 192, which is what we see here of this subnet, 22255.192. If I take 256 and I subtract 32, what do I get? 224. And you can see the pattern continues all the way to the top where I've got 256 minus 4, which gives us that 252, of course. Now, with regards to having multiple networks, we've established, of course, that, the 22255.0 is the normal one. We only have one network. And you can actually go and draw this as a pyramid. There's many ways you can go and draw this. I'm going to try being the keyword, of course, here on the right. So on the right, there's 256 minus 2. So that's when I've got the whole network to myself. 256 IPs, of which 254 are usable. Now, should I, for argument's sake, go and use the 22255.128 instead, that will basically be a case of me taking that 256 and just dividing it by 2. So here we go. I've now got two networks of 128 respectively, and on each of them I can use only 126 IP addresses. So only 126 of them are actually available or usable, as some people might say. So you just keep subdividing that 256 at the end of the day. Now, if you go up another one of this little subnetting table of mine to the 22255 128.192, that is now taking that 128 and just dividing it even further. So now I'm going to have 4 networks of 64, obviously. And on each of those networks, I cannot use all the IPs because I'm going to go and subtract the reserved and the reserved IP address, which is not a broadcast address and network ID. That leaves us with 62 IPs in each of those networks. And obviously, I'm running out of room here because if I'm going to continue any further, I'm not going to have enough room to do this. So the table is just going to continue. Next, we'll have 8 networks of 32, 16 of 16, 32 of 8, and 64 of 4, of course. So that pyramid is just going to keep going down and down and down even further up until when you've got 64 networks of 4 IPs each, of which only 2 are usable. Now, speaking of usable IPs, to clarify a little bit on that, you're probably wondering, so let me first just clear all this nonsense on the right hand side for you guys. So now we've got a little blank black slate there. I would normally say blank slate, but it's not blank per se, it's black. Anyway, so I'm going to look at once more the one at the bottom left, the default 22255.0. We've established that's 256 IPs, of which 254 are usable. Now, what do I mean by that? So if I have to draw this out, I'm going to try it. So here on the right, we've got that. It's going to look like a 0, basically. And then in brackets, I've got a 1-254 and then 255. What does that mean? That means I start counting from 0 all the way to 255. If you start counting from 0 all the way to 255, that is 256. I cannot use the first number. I cannot use the last number. So in other words, I cannot use 0 and I cannot use 255. 0 is the first one, 255 is the last one. Anything in between is what I can go and use, which is now obviously the 1 all the way to 254. So, with that in mind, what my IP addresses for my users would look like is something like this. 192.168.0, it's not set in stone, it's just to give you guys an example, and then .x. The X would, of course, be anything between 1 and 254. So my users, my folks, my clients, my devices, whatever you want to go and call them, their IP will be 192.168.0, and then lastly, anything between 1 and 254. Now, when they do that, they will be on the same network. And they will pretty much guaranteed be on the same network because we only have the one network since we're using a 22255.0, which is clearly just one network. Now, let's give you guys another one. So I'm going to first off clear this up again, giving me that black blank slate. I can't say that with a straight face. Anyway, guys, so using that table of mine again, I'm going to use the next one up on that table, the second one from the bottom, 22255.128. I'm going to try and keep this as simple as I possibly can. So assuming the 0 has now been replaced by .128, that would mean I've got 2 networks, and each of these 2 networks has 128 IP addresses in them, of which 126 are actually usable. Now, what would this look like? So to draw it out like we did with the previous one, our first network of those 2 networks will look something like this. We're going to start from 0 once again. We always start from 0, and we're going to count all the way to 127. So counting from 0 all the way to 127, that is 128. And everything in between, which is now, of course, the 1 all the way to 126, that is your usable IPs. The 0 and the 127 is the non-usable ones, the reserved ones. Now, you would notice we only got all the way to 127. What about all the way to 255? That is when the second network comes in now. So now we're going to start again from 128, which is my first IP, my reserved IP, which is not usable. And we're going to count all the way to 255. So we're basically counting in increments of 128. And now, of course, anything between 128 and 255 is the usable IPs, the non-reserved ones. 128 is the first one, which is reserved. 255 is the last one, which is reserved. And the same pattern is going to continue with all these other networks. If I would have gone and chose the one that's .192, which is now 4 networks of 64, you basically just keep counting in 64s until you get to 255. In other words, counting in increments of 64. The same happens for the 225 subnet one. You would count in increments of 32 8 times. If you look at the subnet of 240, you would count in increments of 16 16 times. If you look at the subnet of 248, you would count in increments of 8, and you're going to be doing it 32 times. And then lastly, the subnet of 252, you'll be counting in increments of 4, and you're going to do it a crazy amount of 64 times. So yeah, that's basically how this works. Now, you can see here on the right, obviously we've got those two networks, still those two networks. Why the heck would I want to go and do that? There's many reasons, but I'm going to try and simplify the living heck out of it, like the title said in the beginning. So I'm going to make two blocks here, purple and orange. Why, you might ask? Because this is going to simulate two different departments in the same building. I want you guys to visualize or imagine these two blocks being two different departments in the same building, in the same office, for argument's sake. So to make this even easier to visualize, let's call the one on the left the finance department, and the one on the right, let's call that the sales department. Now, in real life, if you go and check it out, you'll find that these two departments are probably plugged into the same network, physically speaking at least. So there's network cables. People are using laptops and desktops with network cables, or they're on a Wi-Fi. The point is they are physically connected to the same network. And they both have access to the internet, most likely, and all that normal fancy stuff. So looking at these two different networks when it comes to subnetting, what would the IP addresses for these two networks look like? So they would both still start with something like 192.168.0.x for the finance department, sales department 192.168.0.x again. So you might say, okay, well, that looks the same. Yeah, it does, but hold up. So the last digit there in that octet for the IP address, being that little X there, of course, for both of them, that is not going to be the same. For the finance department, that little last digit, being the X, would have to be something in the one network, and for the sales department, something in the other network. So for finance, it would look something like this. It'll be something between 1 and 126. You would see that at the top in the blue, our first network, the usable IPs was 1 all the way to 126. So for the finance department, you just replace that X with anything between 1 and 126, anything in that range. And for the sales department, you can go and give them any IP address as long as it's something between 129 and 254. Now, when you do that, they're technically physically still on the same network. They're physically plugged into the same network. They both have access to the internet and all that, but they cannot see one another. So the finance folks, when they go into the computer and they browse the network, can they see or access people from the sales department? Nope. Can't see the devices, can't access their resources. And the same can be said about the sales department. Cannot find the finance department people and the devices on the network, nor can they go and access any of their resources. So what would the subnet mask look like for both of these? It's going to be a 222.5.128 for the one and a 222.55.128 for the other. That's going to be exactly the same. So instead of it being the usual 0 that you guys are familiar with, it's going to be a .128. The only thing that's going to change here is you just need to make extra tippy-toe sure that that last digit for the last octet in the IP address is in the correct subnet. If it's not in the correct subnet, you could very well accidentally throw someone into the wrong subnet. Still gonna work, probably, but they're gonna see the wrong stuff. So maybe, just maybe, I went into the finance department, the purple block there, and I gave one of those users an IP that belongs in the sales department. What would happen then? They would see the sales department people and not their colleagues. Now, there could be a reason. Maybe we did this on purpose. Maybe one day I hired an extra finance department person, but in the finance department, physically, there's not a desk for this person. There's not a cubicle or whatever the finance department actually physically looks like. We don't have a desk for this person. That's the point. But in the sales department, there's many open desks maybe on this particular day. So I told this new person I just hired, you know what, dude or chick, go to the sales department, grab a desk, plug your PC in, and there you go. Now, while they're sitting there, we configure that new finance department person's PC on the same subnet as the finance department. So physically, he or she is sitting in the sales department. They can maybe even physically touch those people. But can they find those people on network? Nope. They can only find their fellow finance department colleagues on the network. So, it doesn't really matter where they're sitting. That's the point here. As long as you're on the right subnet, you'll be able to access the right resources. So this is a form of management. It's not really for security per se. At the end of the day, if someone knows what they're doing, they can go manipulate this. It's more from a management perspective to help organize your network. All right, guys, and then lastly, you're probably wondering about that last column I had there on my little table. So we've pretty much explained what the subnet mask one is, what the IPs one is, what the networks one is, but what the heck is that CIDR one? We refer to that as the CIDR notation. And something you guys are going to encounter a lot, not just in the CompTIA Network Plus exam. Yes, this is an exam. You're going to encounter this in real life all over the place, is that CIDR notation. It's going to look something like this. Here is an IP address on the right. And you'll notice there's a CIDR notation behind the IP address. That is what you can expect in the exam. They will give you a random IP address in the exam, kind of like the one I've just given you, and there's going to be a random CIDR notation behind it. And they will expect you to know what the subnet is for that, how many IPs is available, how many networks is available, all of that. You need to know that. Now, normally you have to go and work it out, and there's nothing wrong with that. You can do that. In all exams, not just CompTIA, you normally get like a little board that you can go work the stuff out on. It's normally like an A4 size board, usually like a whiteboard kind of deal. And you normally get like a whiteboard marker kind of thing, black whiteboard marker or something like that. And this is so that you can go work stuff out in the exam if need be. And this is usually a case where you're going to have to go and work it out. There's probably like 20, 50 different kinds of ways you can go and do subnetting, and none of them are wrong. They're all right. At the end of the day, I encourage you guys to go and look for one that works for you. If mine that I explained to you guys today doesn't make sense, I know many. I'm only simply explaining this one because this is one of the easiest methods to explain, especially for folks that don't have a mathematical background. So if mine doesn't make sense, I encourage you guys to go online, heck, YouTube, and run a search for subnetting. See if you can find one that works for you. What works for me or what works for the next guy might not work for the next guy. So you need to find one that you like and it works for you. But you'll notice what they all have in common is, well, most of them at least, is a lot of math that you're going to have to go work out. Using my table here, which you can basically call a cheat sheet. It's not really a cheat sheet, but you might as well think of it as a cheat sheet. You don't even have to go work it out in the exam. You just write down this table before you click on start in the exam. And as soon as you get any question like this in the exam, you'll pretty much instantly know the answer, saving you a tremendous amount of time. Now, looking at that IP address we have got there on the right, with its CIDR notation being 28, if I would have gone and asked you, what is the subnet mask for that? If you look at my table, you can clearly see it's 222.5.240. Bam! In a fraction of a second, you would know the answer. If I would have asked you how many IP addresses is available in that subnet, or how many IPs is available of that CIDR notation, you can immediately see 16 IPs with -2, of course, which means 14 are usable. How many networks is that? 16 networks. You can see it using my table. So for any question they ask you in the exam, you can almost instantly work out the answer. You don't even have to work it out. You can literally see it on the table. And this is not cheating. This is just a sheet. And you're going to get to a point in time where you're going to know this table off by heart in your head. The beginning, there's no freaking way you're going to know it off by heart. So you're going to have to write it down in the exam. And you might think, oh, but there's no freaking way I'm going to remember this table. No, it's not as complicated as you think. Start at the bottom here with this little first row, 222.5.5.0. We know it's 256 IPs, of which, well, 2 of them are not usable. We know it's one network, so you might just need to remember it's a CIDR notation of 24/24. From there, the rest is just going to fill itself in. So looking at the CIDR notation, just keep counting up with increments of 1. And looking at the networks, you just keep doubling it. So it's 1, 2, 4, 8, 16. You just keep doubling it. If you look at the available IPs, you just keep subdividing by 2. Now you might say, okay, but how the heck do I work out the subnet mask itself? We know it's 222.5.5 dot something, but what is that dot something? You would remember earlier I actually showed you how to go and work that out. You take that 256 with the IP addresses and you subtract the IP addresses. So if I take 256 and I subtract that 128 from 2 networks, that gives me its subnet, which is, well, 128. If I take 256 and I subtract that 64, it gives me 192. If I take that 256 and I subtract 32, it gives me 224. So now you know what those magic numbers are and how I actually got to them. So you don't need to really memorize it per se. No, you can actually fill it in, but it's going to auto-complete itself for the most part. So I hope this has made sense to you guys. I'm going to once again recommend you go out on YouTube, not necessarily on my channel, this could be anyone's channel, and go look for subnetting. I'm encouraging you guys to go and do that. Even if mine makes perfectly sense to you, just go have a peek at what other methods there are out there. There's many methods, and they're all correct. There's none of them that's right or wrong. See if maybe one of those doesn't maybe make more sense than mine. You might just find one that you like even more than mine. So yeah, you're probably going to like mine because mine's pretty easy. But you never know. You might find something that actually is even better than mine. There's always someone better than you or another way of doing something. The end of the day, my goal is to help you guys for free, of course. And if that is to, tell you guys to go to other people's channels and tell you, hey, go look for other subnetting methods, then so be it. My goal has been achieved, is to help you guys. So with that being said, guys, that is today's lesson. I hope you've learned something, hopefully. If you have, give the video a like, of course. And if you'd like to know when this next lesson comes out, like usual, subscribe. And then lastly, folks, before I disappear on you guys, just a special thank you for the sponsors of this channel. So thank you very much, guys. I appreciate that. And if any of you guys would like to do the same, you can find out the information in the video description down below, like usual. Okay, guys, peace out. See you on the next video.